In this last example, we will solve three statements. We're going to solve h of x equals k of x, h of x is less than or equal to k of x, and h of x is greater than k of x. And we're going to solve using the graph of the two functions. Notice I haven't given the equation of either function, I've simply given the graphs. The equations aren't necessary if you have the graphs using the techniques we've been talking about in earlier videos. So the equations are unnecessary. If you have the graphs, you can compare where they are against each other and solve these equations and inequalities. First off, we need to make sure we recognize which graph is which. First, I've given them in different colors, but I've also described them here. H is the red curvy graph, so the graph here that starts up here at 120 or up high and it's coming down. This is y equals h of x. And then the line, the blue line, is k. So this is y equals k of x. So I'll label them here so we don't forget which is which. All right, so let's start with the equation. If we want to solve h of x equals k of x, recall that if we're solving with graphing, we want to think about where the right side of the equation and the left side of the equation are equal, or where, in other words, where the graphs are the same. That would be where the graphs intersect. So we're looking at where the graphs intersect to solve this equation. So to do that, we look at the graphs, and I've actually highlighted already where they actually intersect. We've got one intersection here at negative 1.83, 40.822, another intersection point at 1.183, 16.538, and another intersection here at 8.67, negative 43.36. Now I've given the coordinates of those intersection points just to make it easier, but on your own, you could have approximated where those are if you weren't given the coordinates. The main thing is to note is that it's where the graphs intersect. That's where the equations are equal. The two sides of the equation, h and k, are equal. So to solve this, we want to go ahead and respond with the x values. And generally, we want to show them out to the same value if we need to round them off. And since the third point is to the second place, let's make all of our solutions out to the second place. So negative 1.85 would be our first solution on the left. In the middle, our intersection would be 1.18 as the x value. And then the solution on the right would be 8.67. So we have three solutions to this equation of h of x equals k of x. So three solutions, there's our solution set in braces. Now to move on to solve h of x is less than or equal to k of x, remember we're going to still look at the two graphs, but we need to remember what are we looking for. Well, h of x here, according to the statement, we want it to be less than or equal. Less than or equal means we want it to be lower or equal to k of x. So we want to examine the graph and think about where that occurs. So let's do that. Coming over here, we want to look at where h is lower or equal to k. Now remember, h is the red graph. Well, think about where it ends up lower than the line. Well, I see one region here between these first two intersection points here, from negative 1.83 to positive 1.18. So we have one region where the red graph is below the blue graph right there. Now to show that as a solution set, that's all the points between those regions, so we would use an interval notation. Now I'm starting with a parenthesis, but let's consider that. Let me write down the first x value, 1.85, and we're going to 1.18. And I used a parenthesis because it's kind of habit just to write down the parenthesis. But remember, we can also let these be equal. To let them be equal, that means we can be on the intersection. So I actually wouldn't want to use a parenthesis, I want to use a bracket. So I'm going to change that to a bracket, and then I'm going to close with a bracket because I can be equal on the other side as well. Now looking at this graph, let's see if there's any other spot where the red graph is below the blue graph. When we continue through this graph, the red graph is above in this next region, the red graph's all the way above, but then when we get to the third intersection point, once again, the red graph will end up going below the blue graph. One thing to note is that these graphs continue on past where we actually see them on the grid. If your graph goes to the edge of the grid, it's assumed that it continues in that direction forever. So technically there are little arrows on the edges of these two graphs. So this continues down forever, this continues down and to the right forever. So we actually have that red graph being less than the blue graph from 8.67 all the way out to positive infinity. So to finish up my solution set here, I would actually say that my next region, and here again I accidentally put in a parenthesis. It should be a bracket because remember we can be equal, the two graphs can be equal for this to be a solution. I would start at 8.67. My 8 looks a little weird then, let me try that again. 8.67. And then because it continues forever in that direction, I would say infinity. Now it's tempting to say negative infinity because the graphs are going down, but remember we're talking about x values, and the x values out to the right side are positive infinity values. Now with infinity you always use a parenthesis, so we'd finish that off with a parenthesis. You never use a bracket with infinity because infinity is the idea that you go forever and ever, not that you ever reach it. All right, now I made this a little messy, so let me erase some of the highlighting here that I've done, and just to make it easier to see in our next question. All right, in our next question, our last one, we have solve h of x is greater than k of x. H of x is greater means that we want to look for when h is higher than k. So to look at when h is higher, look at the two graphs. Again, if you look straight up and down, you can see the red graph is higher. Get my highlighter working. Before you get to the first intersection, to the left of the first intersection, you can see that h of x is higher. It's above the blue line. So the red graph is above the blue line. So that means that we actually have from all the way to the left, so remember going to the left is negative infinity, we're going to have negative, whoops, I need to get my coloring straight, negative infinity, all the way up to where we have this first intersection point, which will be at negative 1.85. That would be values where h of x is above k. Now notice there's no equals here, so we would use a parenthesis instead of a bracket. And then let's see if there's any other regions where h is above k. Well, there's one big region right here. We have in this whole big region where h kind of comes up and has a peak before coming back down. We have a place where the red graph is above the blue graph. So in through here. Now all of those points are points where h is above the blue line, the k graph. So we want to include all of those values. So once again, using an interval of numbers. So we're going to union this from 1.18 to 8.67. Once again, I'm using parentheses because there's no equals on this statement. We're just looking at h of x is greater than k of x. So remember, when you're solving with a graph, you're looking for where a graph is above or below the other graph. And when we talk about the graphs, we're talking about the left side and the right side. So technically, if you're given the graphs, you don't need to know what the actual expression for the functions are. You just need to have the graphs of the left and right sides. And that's what these graphs of h and k are giving us. No expression for them needed. We just need the graphs.